Today we're going to do the FRQ process for a test. It's our first time doing the whole thing. Now let's pretend that this said interval. One sample Z interval for P. Let's just pretend. What would you do in the state for an interval? Chapter 8. Yeah, 95% confidence interval for P equals the true proportion, and then write the words from the problem. Does that make sense? Okay. For a test, because it's a hypothesis test, you want to state your hypotheses. You want to define the parameter and state your alpha level, your boundary. Because remember, we said you should state the boundary before you start, because if you do it after the math, that's cheating. Okay, now let's pretend that you're back in chapter 8. What would you do for the plan? Say the method, then random, 10%, large count. It's exactly the same for this. However, the word interval changes to test, and that's it. So okay, now you notice that I left 2 lines here. And that's because there's just something I want to make sure that we refer to for large counts. So okay, what do you guys do for the large counts condition? Okay, and you guys are like, yeah, duh. Why are you making us write this again? Well, in chapter 8, I had deviated from that. And I'm not talking about the successes and failures of it. I'm talking about the fact that we didn't have P, so we used P hat. I want to pause here and tell you that on the back of this, if you guys can grab your yellow sheet, we're going to use the yellow sheet today anyway, but just grab it and let's look at the bottom. And I know I read this, I think I even said I wasn't going to read it again, but here I am breaking my word. Okay. Standard deviation is a measurement of variability from the theoretical population. Standard error is the estimate of the standard deviation. If the standard deviation of the statistic is assumed to be known, then the standard deviation should be used instead of the standard error. Okay, you're like, I lost you, Mrs. Talbot. That's cool. That's awesome. The rule here, and if you guys could take whatever pen you've been using to write on this, we're going to translate this to teenager. This is what this is trying to say. They could have taken that whole 2 lines and written it to this. Use P if you have it. If not, use P hat. P is always better if you have it. And now, why would we have it in a test, but we wouldn't have it in a confidence interval? Okay, let me flip back to here. This is our notes from Friday. Why would we have P for a test, but not for a confidence interval? Because you're saying what P is in your hypotheses. In a test, it's a little different because you have a claim of what's happening currently. You've got past information. You've got old info you can use to go off of. So you're going to use P because you have. If you can just remind yourself that for a whole year, if you have P, use it. If you don't have it, you'll be fine. But I just want to make sure that you're using P in the conditions specifically. So in our notes for today, what I'd like to do is highlight the P's in this problem, and then we're in this, and then we're going to highlight the P's in the do also. Okay, now in the do, what is the answer to a hypothesis test? What's the vocab word for the answer to a hypothesis test? What's the thing that you compare to the boundary? You might need to flip back to your 9.1a. What's the vocab word for the answer to the hypothesis test? The mathematical answer. P-value. P-value. And you probably didn't come up with that because we haven't calculated one on our own yet. So it's like, that's how do we get the p-value? So for us, we're going to get the p-value by following our yellow sheet. So I want you guys to find this box on your yellow sheet, please. And you see how this says test in it? That means you're doing a hypothesis test as opposed to a confidence interval. Okay, so if you guys could write chapter 9 right here, and then we're going to copy this into our notes where it says do. And then, do you guys see where there's a colon here? I'm going to change that into an equals. This should be a formula. This should be equals. I don't know why it's not equals. We can actually make it equals if you want. I'm fine with you guys putting an equals in there. Okay, so what we're going to do next is we are going to translate those words, which are very generic and are for all hypothesis tests, to just the one about a one sample proportion. Okay, in a one sample proportion, the standardized test statistic that we're working with is Z. Because this is the letter that we're using here. It's a Z test. So we're going to find Z. Okay. Now, statistic comes from your sample. What's the symbol for sample proportion? P hat. Parameter comes from your population. What's the symbol for your population proportion? P. Do You guys see how I'm trying to get it so you can translate this off of your yellow sheet. Okay, now standard error of statistics, flip the page over, your yellow sheet over. Okay, what do you think it is? Okay, can you narrow it down to two? Let me ask you that. Can you tell that you're in the one population line? Okay, so the question is really, is it this or is it this? And I'm going to ask you to look at what you wrote at the bottom of the page. What did you write at the bottom of the page? Use P if you have it. If not, P hat. Do you have P in these problems? Yes. Okay, so come back over here just because I love you. Okay. So we have square root P times 1 minus P over N. Take your highlighter and highlight all three P's. This little bit is for my visual learners. My visual learners will be able to go, oh, because we highlighted this in our notes, I know that this number and this number and this number are all the same number, because you can like visualize that highlighting in your mind when you're doing the problems. If the second number matches both of the numbers in their standard language. Okay. All right, so you're gonna get Z. And then you're going to use Z in normal CDF to get the p-value. And you're going to use 0 and 1 for your mean and standard deviation because that's what you use when you have the Z-score. So if you guys look back at my poster, back here, magnet giant thing, you guys see the big numbers, -3, -2, -1, 0, 1, 2, 3. Those are Z's. And the mean is 0 and the standard deviation is what? Those are the numbers you could definitely pass on an eye test. Right? Right. Could you imagine if you're at the eye doctor and they brought up the normal curve and they were like, could you please read the Z-scores from left to right? That'd be great. That'd be hilarious. Anyway, okay. You know what? I'm going to actually give you more info here than I was going to. And we've been practicing writing that sentence too. Okay, so now we're going to do a problem about Bernardo. I brought him today with his little tractor ball. So while you're doing the arts and crafts and setting this up, I would like you to think about how Bernardo does catch the ball with no arms. That would be what I'd like you to think about. His mind, mind powers. Maybe he takes his little foil and like makes arms with it temporarily. Or that can 32. It's not bad. Yeah. What do you think, Kaden? You think he makes only arms out of foil? You think he moves it with his mind? Yeah. Feel free to sketch Bernardo off to the side. I have enough Bernardo stickers for next year, I checked. Mhm. Do you have a big week, Cameron? I'm sorry. You do too. Access between, access between. Your face.
I think this today, so then on Thursday.
Yeah. Oh, yeah, yeah, yeah.
Thank you. It's gonna be, because there's a lot of that, I feel like I would have like, yeah, it should be. Yeah, but we have a. But there should be. There's someone always be. Yeah, well, I normally. So there's not a quad that's legit. Thank you.
Okay, guys, let's do this. Okay. Bernardo is bragging about his trash cabal talent. He claims to be an 80% shooter, but his team doubts his claim when he gets p hat equals 32 out of 50 shots, which is 64%. Does his sample proportion provide convincing evidence at the alpha equals 0.05 level that Bernardo is less than an 80% shooter? So you're asking yourself, is his sample proportion so low that we can tell him he's not really an 80% shooter? Because now you're skeptical because he said 80, but he only got 64. And you're okay. So the question is like, how far off is 64% from 80%? Okay. So in the state for these, you need four things. You need the ho, you need the ha, you need to say what P is, and you need to state the alpha level, which in this problem comes straight from the problem. And remember what I said Friday, if it's not in the problem, use 0.05 as a nice middle ground. Okay, so what is the claim, the current claim? So what's the statement of nothing is going on, 80%? Okay, great. So and what do people suspect less? Okay, just a note, chapter 8, this would say something like 95% confidence interval for P equals the true proportion of shots made by Bernardo. Does that make sense? Okay, plan. What is the inference method? One, yep. Sample Z test for P. Remember, chapter 8, it's one sample Z interval for P. Okay, Z equals. Okay, so we look up here, statistic minus parameter over standard error. Okay, what's the statistic in this problem? 0.64, right? So remember, statistic means sample minus population proportion. We have stated we think it's 80%. Well, we have to assume that till proven guilty. Poor Bernardo. Yeah. Oh, I forgot. Look at what I skipped right to the. Hmm. I'm so excited. Yeah, I didn't do the plan. I just skipped over my plan completely. Okay. Now, do you see random in there anywhere? No. Assume, right, great. Perfect. N equals 50. I could visualize Bernardo making 500 or more shots. Sure. With no arms. Okay. What's N in this problem? 50. And what's P? 0.8. Ooh, man, right on the border, Bernardo. Whew, that was close. Okay, now it's time for what I was doing before. Okay, sample proportion minus population proportion. Okay, now be really careful with your order of operations here. If you're going to type this in one swoop, you need to put parentheses around the top. What I would do is just do this in two swoops. I would do 0.64 minus 0.8, enter, and then divided by this. Because if you do this divided by this, it's just going to divide the 0.8, not the whole thing. So I would do an enter in the middle, personally. Oh, no. Oh, my goodness. Must be Monday. And I usually round my z-scores to 2 decimals. All right, now, because I am a seasoned professional, I am a hypothesis test black belt, maybe 4th degree. I can tell, it's not really required to be 4th degree, this isn't that exciting. I can tell that we're going to reject the null hypothesis right now. I know, okay, because negative 2.83z is down here, which is really unusual. Right, so my boundary is gonna be above that, I can already tell. So when you get a really high or really low z-score, you can kind of use that to help make sure that your answer jives as you're doing normal CDF. Okay. Okay, now this, I want to do this one time, maybe more than one time. We're not going to draw a picture every time, but I really want to make sure we have good understanding and we're not just going through the motions. So first of all, this is 0, -1, -2, -3. And negative 2.83, I'm just going to go, just going to make that little picture. I want you guys to see how unusual that spot is. And I'm going to use my picture also to help me write my normal CDF because if I'm in this tail going this way, that's sideways. My low, and I know this is chapter 2, but I just want to bring it up again. If your tail's going this way, your low is going to be negative infinity. Your high is negative 2.83. Okay, everybody find your normal CDF on your calculator because it's been a hot minute. It's in second vars. Zero 0.0023. Okay, now if you guys have a different color, anyone has a different color, if you don't, it's totally fine too. Alpha is 5%, correct? Okay, so according to my percentiles here, where would alpha be between what two z-scores? -2 and -1, probably a lot closer to the -2. Does that make sense? Between -2 and -1, a lot closer to -2. So I'm going to put a little dash in here in a different color and mark that alpha. I want you to see that your p-value is lower than alpha, meaning that it's really, really unusual sample, meaning that we get to reject the null hypothesis, which means that we get to use the party emoji in our brains. The one, the little like cone, and it's got like the little confetti coming out. Like you should have that in your brain every time you get to reject the hoe. It's great. Okay. Anyway. Rejection. I always picture like also like Roz from Monsters Inc. And she's got like a stamp that says like rejected on it. And she like hits it on the paper like super loud and it goes like ka-ching. Cause like that's exciting. She gets to reject Mike Wazowski's Puce copy because he didn't fill out his Puce copy fully. Anyway. Okay, so you're right. We have convincing evidence because we rejected the hoe. We have convincing evidence. So then you scroll up your brain to the ha and write the ha in words. The true proportion of shots made by Bernardo is less than 80%. And then I feel really bad because Bernardo's super adorable. He's probably going to be sad. Okay, I of course have one more thing to teach you today, but I want you to humor me for 2 minutes. First, let's pretend you were in chapter 8 instead, and this was a confidence interval problem. Look on your yellow sheet. What's the formula for a confidence interval? Statistic plus or minus critical value times standard error. Okay, so let's just plug the numbers in our brains. It would be 0.64. Does that make sense? That's a statistic from the sample, plus or minus probably 1.96. But we need to talk about critical value in a minute as it relates to alpha in a second, but hold that thought. Times square root 0.64 times 1 minus 0.64 over 50. This is done. Why would it be 0.80? Well, you wouldn't have that in an interval. You wouldn't have any previous information or previous claim that you're going off of. So that number in the front always matches the numbers underneath the standard error. Okay, second thing I want to ask you, and I'm just trying to review your chapter 8 off the cuff here because I love you, but what if we rejected the null hypothesis? We're excited, but are we like fully 100% sure that we did that correctly? No. What type of error could we have made? Type 1. Type 1. Type 1, because we did not fail to reject, right? So if we had failed to reject, we could have made a type 2 error, but we made a type 1 error because we rejected. Which means that he just had a bad day on that sample, and then we decided that we were going to be like, oh, well, you're not 80%. But the sample might have been wonky because he was having a bad day. Actually, I really think 32 out of 50 shots is pretty good if you have no arms. Okay. Yeah. So I went to here. It's like I wrote on this line and then I wrote on this line. So 2 lines above the hole, the middle hole. You can fit it. You can fit it. And this particular section is extremely spread out because that's who I am.
I will think, or super fun. Probably negative, probably negative.
You guys, I posted the test topics, correct?
Yes.
Okay.
Oh, I think so. Yeah.
I did. It's, I like scheduled it to do it, and I don't have like the memory of doing it, but I scheduled it, but I'm pretty sure.
Oh, go back to the. You have a pile of those.
All right, everybody, so, on this bit here, I want to relate hypothesis test to confidence level. And this is the first time we're going to talk about tests being two-sided or one-sided. You might also see in the book or on AP Classroom, they call it one-tailed or two-tailed. One-sided is the same thing as one-tailed. The one we just did was one-tailed, because I shaded in one tail on my normal curve. Does that make sense? Okay, and we've only done one-tailed ones so far. You haven't seen a two-tailed one yet. Okay. A one-sided or one-tailed test will have the alternative hypothesis be less than or greater than. So I want you to picture how that would look in the shading of the normal curve. We just did a less than one. What would the greater than one look like? Shade up, right? Okay, so then your low would be Z and your high would be positive infinity. Okay, that's not really what I'm getting at here though. Okay, so I want you to, hey, that turned out pretty good. Okay, so do you remember how I said, we just said that the alpha level boundary would be in between Z of -1 and -2, but closer to -2. Do you remember how I said that? Okay. So dash me in that if you would. Does everybody understand where I got that dash line from? So I worked up to 5%. Okay, now what I want you to do is I'm going to bring your mind back to chapter 8, and I want you to draw that. You know what that is? That is confidence interval. Okay, so if I have an alpha level of 0.05, this is a hard question. It's not an easy question, I promise. If I have an alpha level of 0.05 and my test is one-sided, what would the confidence level be for that? It's not 95. That's the whole reason I wanted to do this. Okay, let me ask you this. What would be the area on this side? 5%. Normal curve is symmetric, which means what would be the area on this side? 5%. So what would be the area in the middle then? 90. Okay, so if you want to, you would have this or this, depending on the problem. But either way, the middle part would be 90. It wouldn't matter if you had a less than or a greater than. the middle part would be 90. Okay, now let's contrast that with the two-sided. What are you saying, Mrs. Talbot? Like, what are you getting at? A two-sided test, which we have not done yet, instead of less than or greater than, it doesn't tell you the exact direction. It just says it's not that. It's not 80%. I don't know if you read this, but hopefully you're seeing what I'm getting at down here. Okay. So in this case, I don't know if I can make it as nice as I made the last one. This is saying that both tails add up to be 5%. And it could be less than or greater. So you're down here. And both of these areas are 0.0. That's supposed to be a 2. 0.025. So when it's two-tailed, it's just saying you have to split that 5% between two areas, which means it's much harder to reject the null hypothesis, sadly. But what would be the confidence level then? That one's 95. Okay, so I just need one more minute of your time. What if Bernardus came dogged that his trash to ball percentage of shots made wasn't exactly 80%? So that's what the wording would sound like in the regular problem. It would say, like, it wouldn't say less than, or it wouldn't say greater than, it would say not equal to. So when you see a word like this, you translate that in your brain to not equal to, meaning if it was higher or lower than 80%. They're just saying, we think it's not 80%. It could be 81, it could be 79, it could be anything else. Repeat the hypothesis test, but only write what would be different from the previous example. Okay, so the only things that would change would be the ha. Instead of being greater than or less than, it would be P is not equal to 0.80. Okay, and then the only other thing that would change in the whole problem is the p-value will change. Okay, so it's still normal CDF. It's still negative infinity to negative 2.8301. And in the calculator, you would still get 0.0023. None of your calculator stuff would change. However, you have to take this final answer and multiply it by 2 because you don't know if you're less than or greater than. So you have to take into account both areas. So if it's not equal to, and only when it's not equal to, you have to multiply the p-value by 2 because it could be low or it could be high. You're not sure. Which is 0.0046. And we would still get to reject the null hypothesis in this one because our z-score was so low, but it makes it a lot harder to reject the null hypothesis. That's it. Did you hit it?
I did.
Now, I am done, but didn't I promise you a good joke today? I'm pretty sure I'm able to follow through on that promise. I found it earlier. Waiting. I was too excited. Is that it for all the arts and crafts for the chapter? No, there's one. Yeah. Taylor, you said? Oh, she's not? Okay, okay. Okay, everybody, this required to look at my joke. This is a teaching joke. Oh, so hope you're ready. We're taking a test, be like, which one is it? Oh, yeah, it's the two, but it's clearly not. I know.
They'll be cutting that thing off every thing. That's what I did.
Same thing 3 times, but he hasn't given me enough.
You're saying.
I used to have about 6 points and I'm gonna see. I used to have to just the box, but now you have to actually big and split and like it keeps everything on after this and then this other right and down the shower my love story log.
Oh.
Yeah, okay, good. I never want to let them know, yeah. My stomach was going off, I was like so scared, it was like, oh my ear was so loud. I was like, what? 5, 6, 9, 10.
Really good. Last time I had I went the first one is I did. And here does look a little like, we still want that. Very well. Yes,
I was like by myself at first, it's like nothing about it.
the, right.
Yeah.
Frankenstein.
I work today, so. It's the gym, it's the,
Oh.
I'm excited for, yeah, like, all of it's fun. Like, the next day, I'm not
No, not that long.
Hi, honey. What joke is it today? What? Oh, I like this one. What is the cute thing? I know. This one, he was like, oh my God.
I don't.
Mike is so busy, so today